The next test we're going to look at is alkalinity. Alkalinity and pH are definitely correlated to one another. So we just talked about with pH that we see alkaline results here because of the underlying limestone. And so because of that, we can then look a little bit further into alkalinity. Alkalinity is looking at that body of water's ability to buffer against an acidic event. So you can think about like acid rain or chemicals that have been released nearby and have somehow found their way into that body of water. The higher the alkalinity, the better buffer it is against an acidic event like one of those. So while alkalinity doesn't tell us much about water quality per se, what it does is it tells us that water's ability to counteract any of those negative types of events. So with this, this is another titration. It's not as complicated as the dissolved oxygen. So with this, I only need 5 milliliters of sample water. And again, I'm just mixing just to make sure that there's no leftover water from a previous sample. That's just a nice way to prevent any sources of error. So I got way too much water in there. And now I got too little. Perfect. Okay, so again, we're looking for a color change. So the first step is I have to take one of these indicator tablets, and this is going to help us change the color. I feel like I'm taking a vitamin. Okay, so what we're going to do is just kind of, there is a hole in this cap. So you want to make sure that you cover it with your finger. It's not going to, there's nothing harmful in here you have to be concerned about. You just don't want your sample sloshing out, okay? So you can see there's this really pretty teal color. I'm just kind of shaking it up just to make sure that that tablet is completely dissolved. And what you'll find is, especially if you're doing water testing different times of the year, this water is pretty warm, so these types of things are going to dissolve pretty quickly. If you're testing, if we came back and tested this, say in January, it would probably take a little bit longer for it to dissolve because the water is colder, just like in any other aspect that you can consider. So it has completely dissolved. So now we're ready to add our titration. So the titrator looks the same, but it has different units on here, and that's important because if you're out in the field, because it looks just like the dissolved oxygen titrator, it can happen where it gets mixed up in the wrong test kit. So you want to make sure when you look at this one that it ranges from 0 to 200. Alkalinity is measured in parts per million. So we're going to see if the range here is somewhere between 0 and 200 parts per million. Remember, the higher the number, the better buffer it can be against an acidic event. So we're anticipating, because it is alkaline, based on our pH results, we're expecting to see something within the alkalinity department. Okay? So what I'm doing is my end color that I'm looking for is purple. So right now it's kind of a bluish green teal color, and I'm looking for it to be purple. This, especially in our area, you may have to fill this titrator up more than once. It may be higher than 200 parts per million. So you may depress the entire thing and it still hasn't turned purple. That doesn't mean you did anything wrong. What it means is that the alkalinity is higher than 200. We're not going to depress the entire titrator though, because we don't know what the alkalinity is. If we put it all in at one time, we're not going to be able to see that color change. So we're going to add and swirl. We're going to add and swirl. And I'm starting to see, when I add it in there, a flash of purple. So I know it's working. Almost. All right, there we go. So what I do now is I take the titrator out, and where the end of it is how much alkalinity in parts per million, and this ended right at 140. So for this stretch of the river, the alkalinity here is 140 parts per million.